Now, if you're anything like me, you probably love a good graph. In today's video, we're going to look at Prometheus and Grafana. Prometheus is a time series database-based monitoring tool. What it does is every few seconds it reaches out and scrapes a remote HTTP target for a bunch of monitoring information. In our case, I need to monitor a UPS that I just added to my UK backup server. I'm going to connect the two together using, of course, Tailscale. Prometheus is running here in my home lab in Raleigh, and the node exporter for APC UPSD is running on my backup server in Norfolk in England. And so we often say around these parts that Tailscale is the easiest way to connect your devices and services together, and indeed that's what I'm going to show you today. So I'm connected into my remote UK server using Tailscale SSH. You can find a link to a video about Tailscale SSH just up here. This means I don't need to manage SSH keys or worry about DNS or any of that kind of stuff. Tailscale just handles it all for me. Now I've connected via USB the APC UPS device to Snowball, and I can see that if I type ls USB, I've got the American Power Conversion uninterruptible power supply. Now you can find a daemon that will allow you to monitor and actually access the data that that USB connection is providing, and we can install that with a simple sudo apt install APC UPSD. That's going to pull down a few packages. Now I'm running all of these commands on top of Proxmox. You might need to adjust a few things if you are running a different OS. Now you might notice here that I've already got an error message saying that I cannot communicate with the UPS. And that's because we need to configure the UPS daemon to be able to connect to the device over USB. So I'm going to bring up Vim using sudo vim etc apc upsd apc-UPSD.conf, and in this file I'm going to make just a couple of small edits. I'm going to give the UPS a name. This will make it easier in our queries later on in Prometheus. I'm just going to call this APC UPS NR. Maybe I should call it Snowball. How about that? I'm just going to call it Snowball. I also need to modify, there is a line somewhere down here that talks about connecting through a serial console. Just need to comment that out. Yeah, here we are. I think all I need to do is just remove this one line just here and then restart, again using sudo systemctl restart APC UPSD. Now if I type sudo apc access, I should be able to connect to all of the information that's being exposed to this host via the USB connection and the daemon that we just installed. You can see the battery charge here is 100%. At the current power usage levels, it reckons it's got about 50 minutes of runtime. The line voltage is 241 volts. And the backup model in question, just in case you're curious, is the BX950MI. And so that's all the configuration that's required to get the host to talk to the actual physical UPS device over USB. You can just take a quick look at the APC UPSD service here and just have a look at what's going on. If you want to make any modifications, you can just modify this file over here to suit your needs for things like shutdown parameters and certain percentages to trigger shutdowns, that kind of thing. Next up, we're going to rely on a project from GitHub called APC UPSD Exporter, and there'll be a link to this in the description down below, of course. We need to clone this Git repo, which is a fairly straightforward process these days. We click on the big green button up here and copy the URL to our clipboard. I'm going to make a directory called Git in the home directory of this particular user, and then do git clone APC UPS Exporter.git. Then I'm going to change into that directory, and I need to also make sure that I've got Go installed on this box as well. So I'm going to do sudo apt install golang, and it's going to go out and fetch the latest dependencies. Now, I already did this before I started recording the video. If you didn't, you'll need to make sure that Go is installed with that command. Next, we need to build the binary itself, and we do this with the following command: go build /command /apcd APC-UPSD _exporter. This is going to build us the statically compiled binary that we actually need to run. Next, this gets deposited in the root of the Git repo, and we can run it with a / and then the name of the binary itself. And you'll see that we now have an HTTP server running on port 9162. So what we can do now is grab the IP address of our host. So I'm going to go up to my devices, get Snowball's IP address, paste this in here, and it was 9162. And we can see this is how the Prometheus exporter, the node exporter, presents information to Prometheus. So what Prometheus will do, we're going to configure that in a minute, it will reach out to this HTTP endpoint over Tailscale and scrape all of this information every 30 seconds, every 60 seconds or so. We can then put that information into Grafana to create our graphs. Now at the present time, this HTTP server is running in the foreground. Long term, that won't do. So we need to create ourselves a systemd unit file. We're going to put this under etc systemd system and then APC UPSD. I feel like I've said that phrase. You know when a word becomes a sound? That's kind of where I am with that right now. APC UPSD _ exporter .service. Then we're going to create the following unit file, and just take note of this path: user local bin and then the name of the binary. I'm going to write and quit that file, and then I'm going to move the binary that we built _ exporter to user local bin as sudo, of course. And so now if we do a sudo systemctl daemon reload, we can then do again, we can do start APC UPSD _ exporter -- now. I'm actually going to change the word start to enable so that it both starts and enables the service right here and now. And so if I go to this URL, we should see that the metrics are now running in the background as a systemd service. So the next step is going to be to configure Prometheus on the remote side. Now I'm using VS Code here to access the node that's going to be running Prometheus in my tailnet. It just happens to be called Prometheus, funnily enough. And in the root of this user's home folder, I've put a folder called compose.yaml. In here, I've defined a couple of containers. The first of them, as you might expect, is Prometheus, and the second one is Grafana. So just a reminder, Prometheus is what's going to reach out and do the scraping from here in Raleigh over the Tailscale tunnel that we have underneath to the server running in England, running APC UPSD. And then Grafana will talk locally on the Prometheus box to Prometheus and query it for data to present it as a pretty graph-based front end. So let's take a look at the configuration that's required for Prometheus first of all. Spinning up the container is really easy, and there'll be code snippets in a link down below to a Git repo that I have for all of the materials that you're going to need for today's video. The second file you're going to need to look at is this one that goes in opt apt data Prometheus. You can see I've got that mounted here as a volume to replace the volume of /etc Prometheus inside the container. Now this is where we define the target scrape configuration. You can see that I've got two targets configured here, the first of which is to scrape Prometheus itself, and then the second is to scrape my UPS. Now, you may not know this, but this particular subnet here is the remote subnet in England, 192.168.16.10. So I've currently got this configured to be scraping that remote host over a subnet router, even though Snowball is actually on my tailnet as well. I could just as easily replace this with the 100.IP address if I wanted to, but I was doing some testing before the video and it sort of occurred to me maybe that would be a nice thing to show everybody here, is that you can scrape devices that aren't even on the tailnet by using subnet routing functionality as well. Just, it's one of those things that, like I said in the intro, Tailscale is the easiest way to connect your devices and services together, and this is exactly what we mean by that. So once we have everything configured in terms of the Docker Compose file and the configuration that needs to be put in place for Prometheus itself, it's time to go and spin these things up. So I'm going to do a Docker Compose. By the way, this terminal window is logged in via SSH to the Prometheus box. I'm not running this on my local laptop or anything like that. I'm going to do Docker Compose up, and it's going to pull down the Grafana and the Prometheus containers as well. So now, if I go to Prometheus, I think it runs on port 9090 by default, you can see I'm able to use the host name here to connect and then port 9090. And I'm connected now into the Prometheus instance that we just created in a container. So if I now jump over to the status tab up here and just have a quick look at the targets that are being scraped, we can see that the state here is up of instance 192.168.16.10 of job UPS. The last scrape was 15 seconds ago, and it took 90 milliseconds to do that scrape. Now, if we jump to this URL here, we can actually take a manual look at the endpoint. Again, note that I'm connected here through the subnet router, but we could just as easily use instead the exact same URL, but using the 100.tailscale IP address instead. Doesn't really matter which one you pick. So let's try and query our first value. I want to know what my charge percentage is. And you can literally just type, you don't have to know much about PromQL, Prometheus query language, to get started with this stuff. Of course, if you want to do some more advanced stuff down the road, the world is your oyster as far as PromQL is concerned. You can do arithmetic operations and things like that and all sorts of craziness. But for today, I think we'll keep it simple. I just want to know what this value is. And you can see I can select things based on instance, job, UPS, the name. Remember, we configured this on the server side in England, APS UPS Snowball. And we can see here that the value is 100. So that proves that Prometheus is connected over Tailscale to the remote server in England. The next step is to try and create some beautiful graphs with Grafana. Now, by default, when you spin up Grafana for the first time, you're going to want to configure your username and password, all that kind of stuff. I think it's admin. I've just got a basic instance here with no data sources or anything configured. So we need to add a data source first of all, something that Grafana can query to grab the data that we want to put into graph form. So data source is over here on the left, and then click on add data source. Next up, click on Prometheus, and we want to put the name, yeah, Prometheus is fine. And I'm going to grab the IP address of the Prometheus box, just so there's no DNS weirdness going on. Not that I think there would be, but by clicking on that in the Mac client, by the way, you actually get the IP address. So I do HTTP and I get 100.67.125.12, and then Prometheus is running on 9090, I think. No authentication right now, and I think if we do save and test, yeah, you successfully queried the Prometheus API. Fantastic. So I'm going to now build a dashboard. I just want to add a visualization using the Prometheus data source, and then I'm going to select a metric, charge percentage, because we know that one exists. And then I click on the Run Queries button up here, and you can see that my charge percentage is now in a Prometheus graph. I could obviously take this a step further and type in, you know, snowball battery percent. Click save. I'm going to call this snowball UPS. And you can see I've now got a dashboard, and I can monitor my UPS battery percentage and anything else my little brain can think of. I could monitor the disk usage with a Prometheus node exporter on the remote system. I can monitor pretty much any sensor that can output a basic formatted list of parameters and sensors. Prometheus can scrape, and it really is a very versatile tool, particularly when you don't even have to worry about firewalls being in the way thanks to Tailscale. So I hope you learned something today. It was a quick and fast video, but sometimes I think the purpose of these videos is more to give you the idea than it is to show you the exact specifics of every single solution possible with Prometheus, because there's a lot. Now, don't forget to get subscribed down below. We have started doing live streams here on YouTube every couple of weeks. You can come and ask me your questions in real time, and we'll work through them together. So until next time, thank you so much for watching. I've been Alex from Tailscale.